Good day everyone. In this video, we will be discussing what is a POSIX semaphore, how to run a POSIX semaphore using Ubuntu terminals in C language. So by the way, I'm Evan Pateño, together with my partner, Mr. Johnny A. Labrador. So when we see POSIX, it is short for Portable Operating System Interface. And when we say semaphore, it is a data structure used to help trades work together without interfering with each other. Thus, a semaphore is an integer whose value is never allowed to fall below 0. So meaning, POSIX is simply a standard interface for semaphore. And now, my partner will demonstrate to you how to run a code using POSIX semaphore in C language with the use of the Ubuntu terminals. So, let's go!
Hello everybody, my name is Jovek A. Labrador Jr. and in this part of the video, I'll be discussing and showing you how to use POSIX semaphores in C language here in Linux operating system. So we have here a C program, a semaphore program that will demonstrate our working of semaphore. So first, here we can see in our program a four bunch of libraries that will handle the input-output, the threads, and our header, the UDSTD, and most importantly, here in our video, the semaphore library, so that we can use the function semaphore here. For example, here the sem_t. Now here in our void pointer function, we call it name, that points to any data type objects. Now inside here in our void pointer function we have a semWait. That is actually the to lap a semaphore or wait. And after that, we have here a critical section that will sleep for 4 seconds. And then we have here in our signal or to semPost, that is pointing to our mutex here in our semaphore. What this code does is to release or signal a semaphore. Now then to our main function, we have to initialize our semaphore called seminit. Here we have 3 variables. The first one is the sem. What this does is it specifies the semaphore to be initialized. And here we can just point it out to this object that we called mutex. This is our semaphore. Now here it is 0. It is the p shared. This argument specifies whether or not the newly initialized semaphore is shared between processes or between threads. A non-zero value means the semaphore is shared between processes, and the value of 0 means it is shared between threads. And lastly, we have an argument here. So I was saying here, our last argument is 1. What this is the value. It specifies the value to assign to a newly initialized semaphore. Now here we created a thread, the T1 and the T2, and this is the call function to create threads, and the address to this is we pointed out to the T1 here, and we're gonna sleep 2 seconds, and then we're gonna create the second thread, and later that we have to join these 2 threads, and then we have to destroy that semaphore. Now let's show this to let's run this in our code, and for that to work we have to open our terminal, then we're gonna run a command. We have to run the GCC, and the name of that program we have here is the Semaphore. That's C and PLP thread LRT. We have to create the output of this to the desktop. Let's just wait for it. Now let's check it out if that output is created. Now that it is created, we have to run this in our terminal. Now let's go back to our terminal, and for that we have to type the dot and the forward slash and the name of that file. Here we just created the a.out, and here it is, our output. It just entered. Now as you can see, it just waited for 4 seconds for it to unlock. For it to acquiring that lock. So the 2 threads are being created, one for 2 seconds after the first one, but the first thread will sleep for 4 seconds after acquiring the lock. So the second thread will not enter immediately after it is called. It will enter for 2 seconds after it is called. So this is the output. The entered just exiting, entered just exiting, instead of entered just exiting output. Now that's all for this video. Thank you for watching.